Okay, so this is the background information for tangents. And if you've taken previous math classes, you know that tangent is the ratio of sine over cosine. This is like really background. I'm not going to test you on this or anything, but I want you to see where the numbers actually come from. So let's use the unit circle. So we're going to plot the point 0, 0, 1, 0, and then I'm going to draw my unit circle. Okay, I'm going to put in the segment AB. That's the radius, it's 1. Okay. The next thing I'm going to do is I'm going to draw in a perpendicular line that is perpendicular to AB that passes through B. Okay, nice. Point C is a point on the circle, and so we know it's going to be our angle. When we move C around, it's moving around the circle. And so usually I'd make ray AC, but I'm going to make something a little different. I'm going to make a line that passes through AC. Okay, so you see I just created a big triangle outside. So usually, I created a big triangle ADB. Okay, now this is going to be in comparison to the usual triangles we've looked at. I'm sorry, so I made triangle ADB, and what I'm interested in is segment DB. That's the segment I'm interested in. I'm interested in that length. Okay, so let's put some other. Well, we're used to like sine and cosine. We know that the height of C. Oh, sorry. So we know that C. Oh, sorry. So we know that CE is the sine, right, of angle CAE, and AE, the yellow segment, that's cosine of CAE. Okay, and the idea is, if we look, we have two triangles here. We have little triangle ACE, and we have big triangle ADB, and we know from a previous geometry class, from geometry, you know the two triangles are similar. ACE is similar to ADB because they all have the corresponding angles are congruent. Both of them have angle A, and both of the triangles are right angle, and therefore the third angle is congruent. Now, these triangles are not congruent, but they're similar. And so the idea is, because triangles are similar, the ratio of corresponding sides are in proportion. So you can say that CE, so I'm going to mix it up a little bit. I'm going to say that, I want you to write this down. CE over AE is equal to DB over AB. I'll repeat that. CE over AE is equal to DB over AB. Height over base is equal to height over base. So the ratios are equal. Well, CE is sine, AE is cosine, DB is some segments, and AB is 1. And so DB is tangent. And that's how we're going to figure out before calculators, you figured out what the length of DB was, or the tangent. So let's take a journey around. So we can see here that, let's see. So when the angle is 0, tangent is 0. That segment is 0. As the angle moves from 0 to 90, we see that D is moving up. It's actually moving up it's moving towards infinity. And we notice that as the rotation, C moves to 90 degrees, triangle CA, what was it? It was triangle ACB. Triangle ACD is no longer a triangle. So you know what? At 90 degrees, tangent has an asymptote. Okay, now let's move past 90, and what we notice is the line that passes through CA. If we look at this right segment, it's now underneath. And so as we go from 90 to 180, we're approaching 0, but from negative infinity. Now let's continue. Let's go from 180 to 270. Once again, we're positive, but we're heading towards infinity. So we have another asymptote at 270, and then suddenly, after 3 pi over 2, as we move from 3 pi over 2 to 2 pi, or 270 to 360, we're coming up from negative infinity towards 0. And so that's how we figure out what the length of tangents is. Let's take a look at the graph of that. So little things before we look at the graph, we can see when the angle is between 0 and 90, tangent is positive. When the angle is between 90 and 180, tangent is negative. When the angle is between 180 and 270, the tangent is positive. And when the angle is from 270 to 360, tangent is negative. Now, let's take a look at a graph of this. So we're going to go to Desmos. And the code I've made is, well, let me change that to 0. And I'm going to start at 0. I'm going to move up in increments of pi over 4. I've put asymptotes at pi over 2 and 3 pi over 2. And we'll slowly watch the graph. It goes up to infinity, then it suddenly comes up to negative infinity, crosses 0, up to, and this is the tangent graph. Everything applies. I'm not going to be asking you identities or stuff like that, and once again, you're not going to be asked this. But this is where the idea of the tangent came from, and that's basically it. So let's take a look at the exercises. And see how you do with this. But once again, here we go. That's it. Excellent.